Gat. Right, good morning, grade 12s. Oh my goodness, it's good afternoon again. Where is the time going? Very, very welcome to this session. Today we are going to again look at organic chemistry, and we are going to look at an ester question. Okay, this is from 2018, November, paper 2. Okay, and I think this was actually question number 2 or 3. So let's just do the housekeeping again. Okay, for those of you who have not received the Drive link, I am putting it in the chat now. Okay, and please remember, if you haven't done so already, to register at Africa Teen Geeks. Today is Wednesday, the 22nd of April. And so after the Google Drive link, I am posting the link for tomorrow's session. Okay, again, guys, the Google link, the Drive link stays the same, but the link for each meeting changes every day. Okay, so I've given you the Drive link as well as the Teams link. All right, guys, remember to say hi so that I know you're there. Okay. And I think that's about it for housekeeping. I'm hoping so. Let's start with this question paper. Okay. Like I said, November 2018, paper 2, question 2. We get a test tube and it's got a straight chain organic acid, ethanol, and a catalyst. Okay, now guys, this one is one that you should have done at school. This should have been your term 1 practical. It is a question that they have the right to ask, and I thought we could look at it today, not just from the ester point of view, but also from the point of view of answering questions related to investigations. Okay, so that is why I chose this question for today. Right, you guys are very quiet in that chat. I feel like I'm all by myself. Okay, so we've got a test tube. It's got a straight chain organic acid in, X, we don't know what it is. Then we add ethanol, we add a catalyst, and we heat it in a water bath. Okay, they then say organic compound Y is produced, and they give us a reaction equation. Right. So let's have a look at the questions that follow. Oh, wait, before we do that, we have to go and look at the important concepts. So, esterification, that top little block that you see, I'm going to zoom it in a little bit. There we go. Esterification, you have to be able to write down the equation, use structural formula for the formation of esters. You need to be able to name the alcohol and carboxylic acids, and you need to be able to write down the reaction conditions. So, whoopsies, I don't want to move that. Okay. The reaction conditions, you need concentrated sulfuric acid, H2SO4, and that is used as a catalyst. Where are you guys? You're not talking to me at all today. I feel very alone. Okay, so naming esters are also important. The first part of the name comes from the alcohol I used, and the second part of the name comes from the carboxylic acid. And the way to pick up that it comes from the carboxylic acid is you look for the double bond O, right? Now, they like asking this question too. Remember that alcohols and carboxylic acids are flammable. The contents of the test tube is flammable. The test tube is not flammable. Ah! Yay, there's people! Woohoo! Okay, guys, we are doing paper 2, 2018, November. This is question 2. Oh, thank goodness. Oh, thank goodness you guys are here. I was thinking I was going to teach myself. Okay, right. I'm going to go back to the question. I need to zoom out. There we go. Okay, so I have ethanol. Ethanol is my alcohol. The organic acid is the one that I don't know what I have. Okay, and they give me a reaction equation. Cool. So here are the questions. And you'll see that these are quite short. And I said that the reason why I chose to do quite a short one today is because I want to also look at how you approach questions when you do investigations. Okay, so 2.1, give a reason why the test tube is heated in a water bath instead of directly over a flame. Okay, now I remember when we marked this question, a lot of people answered the test tube is flammable. Guys, test tubes are not flammable, it's made from glass. The contents of the test tube is flammable. Okay. So for 2.1, sure, that's very skinny. Hang on. That one. Yeah, let's try this again, shall we? There we go, 2.1. You say the contents of the test tube is flammable. And yes, I don't know if that's the correct spelling. Okay, next question. Write down the type of reaction, the formula of the catalyst, and the homologous series to which Y belongs. So, guys, organic acid and alcohol. Organic acid and alcohol means this is esterification. Right? Then they want to have, now very important, the formula of the catalyst. Okay, guys, not the name, the formula of the catalyst. So we know it's sulfuric acid. So it has to be H2SO4. Okay. Then the homologous series to which compound Y belongs. There's compound Y. Compound Y is the thing that we're forming. And so if we are doing esterification, the homologous series of whatever forms has to be an ester. Okay, guys, these are really, really easy questions, okay? Especially since you guys did this as a practical, okay? I think the reason why a lot of people struggled with this question particularly is because we are normally used to seeing a different question for question 2. We are used to seeing that boom, 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 we are used to seeing the table for question 2. Okay. So we've now done 2.2. Now we move on to the slightly trickier question. Molecular mass of compound Y is 144 grams per mole, and we have its empirical formula. We have to determine the molecular formula. Now, guys, this is where it's important to go all the way back to grade 10. And remember the differences between a molecular formula and an empirical formula. Okay. A molecular formula is the whole thing. It tells me all the atoms and in which ratios they are in the compound. An empirical formula gives us the simplest ratio. Okay. So some molecules have the same empirical formula and molecular formula, okay? But especially in organic chemistry, because they get so long and it's repeated so many times, the empirical formula is simplified from the molecular formula. Okay, so we have an empirical formula. Let me just remember H8. Okay, so we have C4H8O, right? We need to take this empirical formula to a molecular formula, and all we have to go on is that the molecular formula, the molecular mass of what we're looking for is 144 grams per mole. Okay? Hey Liam, hey Luke. Contents is the contents. If H2O is produced, the reaction is esterification, or we're saying the reaction is esterification. Luke, you sometimes, not sometimes, if you combust like alkanes, you also get H2O out. Okay. The reason why we're saying that it is esterification is because we have an organic acid and a alcohol, okay? Organic acid plus alcohol equals esterification, okay? Right. Cool. So what I would do in this situation is I would go and calculate the mass of this thing, okay? So how do we calculate mass? We add everything on the periodic table, okay? So I'm going to say, I tend to use this way of writing it. You don't have to. Okay, so it's 4 carbons, each of them is 12 grams per mole. It's 8 hydrogens, each of them is 1 gram per mole. And there is 1 oxygen. Okay. I'm just checking if you guys have other questions while I grab my calculator. Okay, so I get that this molecular mass here is 72 grams per mole. Okay, now the molecular formula is always a whole multiple of the empirical formula. Okay, it's not different, it's a whole multiple. So 2, 3, 4, 5, something like that. Okay. So what I do then to calculate how many times I need to multiply this empirical formula to get to 144, I say 144 divide by 72. And luckily that gives us 2. Okay? That means that I have to multiply each of these with 2 to get to the molecular formula. Okay? There we go, you guys can still see. So it's going to be C, 4 times 2 gives me 8. H, 8 times 2 gives me 16. And oh, there's a 1 there. 1 times 2 gives me 2. Okay, and that is how I get to my molecular formula. I see someone asked if we can work backwards with regards to the empirical formula. You can, I just find it takes a lot of time. So yes, you absolutely can. Just make sure that your maths is sound. Shame, guys, are you struggling to get in today? Okay. So this is the answer that I would pick for question 2.3. Okay, and this would be the method I show. All right, so let's have another look at 2.4. Write down the IUPAC name of compound Y. Now, the fact that this is only 2 marks is actually very sneaky because it makes you think that it's not that hard. But in actual fact, you have to keep in mind that you've got an ethanol too, okay? So there is actually quite a bit of work to getting the name of compound Y, right? So I'm going to show you step by step how I would approach a question like this, okay? Because I think there's so much to it and it's only 2 marks that I think you guys sometimes look at it and go, "Ooh, I don't know," okay? Right. So. I know that I have some or other organic acid. I add ethanol and I get some or other acid out. Sure, guys, sorry, that was a terrible one. And water. Okay. Then I further know that this thing here has got that formula. Okay, we just calculated that. And I know ethanol is C2. Now I have to think 3 H's, another 1, 2 H's, so that's H5. No, H5 with an OH. Okay. Now, the fact that I have ethanol means that my ester is going to start with ethyl something 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 OH. Okay? Now the question is this thing in the middle. Because at this point in time, we don't know what acid we used. Okay? Now you've got to look here. Okay? Ethyl, ethanol, 2 carbons. And so the acid that we add has to have 6 carbons because the ester we get out has 8 carbons. Okay, I'm going to say that again slowly. We have ethanol. That gives 2 carbons. The ester we finish with has 8 carbons in it. That means that whatever this acid is, it has to add 6 carbons to the mix because we need 8 carbons. Okay. Keegan, there won't be a decimal after the dividing when we do questions like this, when teachers set up questions like this. The point that, or how we do it in such a way that there is no decimal. Okay. I can understand why this is a worry for you. Okay. If for some other bizarre reason you get, say, 2,00001, then it's 2. Or if you get 1,999, then it also becomes 2. But 90% of the time, 90% of the time for a calculation like this, we have worked it out so that it works out to a whole number. Okay, Zuzu, we are busy doing 2018 November paper 2, and we are busy with question 2, which is a question about esters. Okay, let's get back to this naming problem here. Okay, so we know that this thing needs 6 carbons. Okay, which means this thing here should be hexanol. Okay, and remember that hex there tells us what name goes there. Okay, so that is how I would approach a question like this. I would go, look, how much does the ethanol contribute? 2. How much does the acid therefore have to contribute to get to 8? 6. So it has to be, oh, guys, not hexanol. Sure, that was a big mistake of me. I'm sorry. I always write the alcohols first. That's why I get confused. Okay. There's ethanol. So we have to have hexanoic acid. That's better. Okay. So ultimately, this here will be ethyl hexanoate. Okay, they ask for the IUPAC name of the compound that is formed. Just want to take you guys back to the question. The IUPAC name of compound Y. Okay. Last one for this, we have to write down the structural formula of the acid. Okay. So when we figured out the name, we had to figure out what that had to be. And so 2.5 is now pretty easy. Okay, they want the structural formula. Okay, hexanoic 6, 1, 2, 3, 4, 5, and 6. Oic acid, you can put the carboxylic acid here or here, it doesn't matter. So double bond O. Always remember to show the bond between the oxygen and the hydrogen, please. Okay, so I've now drawn hexanoic acid. All I have to do, count to 4 and add the hydrogens. And done. Like, that is that whole question. Okay, you guys feeling a little bit better about organic chemistry? It's not that hard. Okay, so what I want to do now is I want to talk to you guys about dealing with questions that have a a route in practical investigations, okay? Because I sometimes think that you know what to do, but you don't always know how to put it in words. Okay, so that's what I'm going to try and do. Okay, we're going to look at different types of questions that they like to ask in terms of practical investigations. And then if you guys struggle with practical investigations, remember to use your Q&A, okay, and drop me a message so that I can address it. Remember, you will always get a practical investigation. Always. Paper 1 and paper 2. Okay, right. So, the components of a practical investigation in terms of a question paper. They can ask the independent, they can ask the dependent, they can ask the constants or the controls. Okay, they can ask you for a investigative question. I've seen them ask for a hypothesis. And then the favorite question that they have at the moment, especially when they do it in organic chemistry, is this. Is the investigation a fair experiment? Okay? And the reason why I say that is often that one throws people because you see it and you're like, well, what? I don't know. Okay, so let me run you through my thinking process whenever I'm dealing with the words that we see in front of us. Okay. Now, if you have a graph, okay? Oh man, they give us graphs? No. Yes, they do. If you have a graph, then your independent will be on the x, okay? So that will be on the horizontal. Your dependent will be on the y, which is your vertical. Okay? But if they don't give you a graph, you need to ask yourself a question or two. Okay? So what I like to ask myself is always, what am I measuring? Okay? And now, for some other reason, oh, I found more questions. Hang on. Luke, why are we putting ethyl first? Luke, when we give the name of an organic compound, we always put the alcohol first and then the acid. Okay? Guys, in the drive, there's a Word document called Important Concepts. I pulled this straight out of that. Okay? Too big. The first part of the ester always comes from the alcohol, and the second part of the name always comes from the carboxylic acid. And if you are given an ester, you get the structure of an ester, and you're not sure which part belongs to the alcohol or which part belongs to the carboxylic acid, then you look for the double bond O. The double bond O in the ester structure is attached to the carboxylic acid. Okay, Luke, I hope that answers that question. Okay, I hope that helps, guys. I'm quickly going to pop back to here at the bottom where we're busy with our independent and dependent variables. Luke, if you need me to draw you a whole reaction so that I can explain it to you in the structure, please let me know. Okay, sometimes it helps to see it like that as well. Okay, so if I just get told what the learners do, what they investigate, okay, and I don't have a graph, right? What I do then is I ask myself, what am I measuring? Okay. So with boiling points, say for example, the investigative question is with boiling points. Then that means that I'm measuring the boiling point of something. The thing I measure is, oh, sorry guys, that's very skinny. I think I have completely changed my zoom on my board, and so nothing is the way they were yesterday, but that's okay too. Right, so the thing I measure is the dependent variable. Okay, so if I'm doing a boiling point question, then I'm measuring the boiling point, and so the boiling point will be the dependent variable. If I'm working with forces, let's say Newton's second law, okay, then often for Newton's second law, I'm measuring the acceleration. And so the acceleration is the dependent variable. That means that the thing that I consciously change is the independent variable. So the thing I choose is the independent variable. Okay, so that's how you distinguish between those two. Now with your investigative questions, I see this time and time again, it needs to be a question. Grr. And it must contain, sorry, your independent and dependent variables. Okay, you can't have an investigative question I don't know. You can't have an investigative question if you don't have both. Okay. Now for organic chem, they often ask the boiling points. Okay, and I've seen them ask, give an investigative question for this. So you start by saying, what is the effect? I'll move down a little bit. Let me go sideways. Now I changed my mind again, going down. Okay, so you would start your sentence with, what is the effect? Okay, and then you would go of independent variable on blah, 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 which would be your dependent variable. Okay, so for example, if I'm doing a boiling point question and I've got different functional groups, let's do different functional groups. If I have different functional groups and I'm asked for an investigative question, I would say, what is the effect of different functional groups, the thing I choose to change, on boiling point, the thing that I'm measuring, and then question mark. Okay, they do pop up every now and again. Don't think you're not going to get it. Okay, and that brings me to the control and how the control and this question here links together. Okay, I've seen this being asked a few times. They ask, is this investigation a fair experiment? Yes or no? Explain your answer. Okay. Now the trick with something like that is you need to go and see, is there one independent and one dependent variable? Okay. For example, I see it a lot in the boiling point question. They give you a whole long list of, say, alkanes, okay? And they make the chain longer every single time. And then they investigate the boiling point, and then they ask, is this investigation a fair experiment? Okay. The trick with answering that question is you need to go and look, is there maybe something else that they are busy changing? So say, for example, they are changing the length of the chain as well as the functional group. Then that investigation is no longer a fair experiment because I have two independent variables. I'm changing the chain length as well as the functional group, okay? And both of those things influence the boiling point, okay? So when they ask this question, like I say, I've seen it a few times. I get the feeling that they're trying to have people think, and then I think you guys get a little bit stuck. Just always go back to what is good experiment protocol, okay? Good experiment protocol says that I am investigating the relationship of one thing on another, two things. I control the independent variable, and I want to see what changing my independent variable does to my dependent variable. If I have too many independent variables, too many is anything more than one, then I don't know which of these influences my dependent variable. Okay, guys, that is like a super, super important concept that I want you guys to keep in mind. It is unlikely that they are going to ask you a hypothesis, okay? Because remember, a hypothesis is simply an educated guess. It's a hunch. Like, what do I think's going to happen? Okay? And the hypothesis will be correct as long as you, again, have your independent and dependent variables in there. Okay? So I think the longer the chain, the higher the boiling point. Okay? That is your hypothesis. But they do sometimes ask for a conclusion, okay? This investigation fair experiment? Normally 2 marks. 1 for the yes or no, 1 for the reason, okay? And the reason is super, super simple, okay? You don't have to go into too much detail. You simply tell the examiner, only one variable is changed during the experiment. Okay? Now, you could say chain length. I'm just giving you examples. I'm not saying this is always that way. Okay, so if they have alkanes and the alkanes get longer and longer and longer, like yesterday's question, okay, then you say the chain length is being changed while all other things stay the same. Okay. I like that because you're independent of your X. I learned it a little bit different. Okay. Luke, fair enough. If you do still struggle with that tomorrow, please let me know. Okay. I also really struggled with the naming of the stuff for a very long time. Okay. The independent variable is the manipulated variable. Dependent response to the manipulated variable. Yes, good job, Keziah. Okay, guys, so I hope that helps a little bit in terms of answering questions that have got to do with investigations. Okay. Like I say, you are going to get one in question one, in paper one, and you're going to get one in paper two. Okay, it's a given. There's no way around it. Okay, so you need to just be careful and be comfortable with all of these ideas. All right, guys. So if anyone has any questions, now's the time to put them on there. If you want me to go back to any of the answers, also do so. I am just going to remind you of tomorrow's team link. And for those of you who don't yet have the drive, there is the link to the drive as well. But seeing as you guys got here today, I'm pretty sure we got it. Okay. For the extra detail, what extra detail? This is all part of your science thinking. Guys, I want you guys to also realize that yes, science is a lot. I'm not taking that away from the subject. I know how much it is, okay? I'm well aware, because at the moment I'm busy making notes, and then I realize how easily I just teach because all of this knowledge is just stacked in my brain. But now I'm having to like put it down because I can't give it to people like this, okay? So I get how much it is, and like I said to you guys in the beginning, I feel my job here is to best prepare you for your final exam in the situation we have using the tools we have. Okay, so for example, we are supposed to be doing chemical change, but chemical change is tough. It's tough. And I looked at it and I thought that there's no logical way for me to help you with chemical change, to teach it from scratch, because you wouldn't have done it before, if I couldn't get more interaction than we can on the best of times on this platform. Okay, and that is why I thought this time would be better spent revising organic chemistry, because it's the first 3 questions in your paper 2. Okay, it's heavy. And then the other thing, that's why I want to look at fertilizers on Friday. Fertilizers always gets chucked at the end. Okay, a lot of people don't look at it. And so I'd like to give you a flow diagram just to help you out. Nira wants to know, how do we know which experiment is the control if we're giving 2 experiments? That is a difficult one. That is a really difficult one. The control is normally the experiment that does the opposite of what you're hoping it to do. But Nira, that is a difficult question. Owami, yes, the links change every day. Owami, here's the link for tomorrow. Okay, so get it now. Get it now. Guys, make sure you have this link now. It changes every single day. There is a Word document in the drive with all of the links for this week. All right, guys, everybody happy? Not too bad, hey. Good job, guys. Okay, so tomorrow we're going to look at organic reactions, okay? If you go look in the folder, I gave you a beautiful flow diagram of all the reactions and how they work together. And there's a table with reaction conditions in there as well. Those you have to know. All right, guys. Thanks so much for joining. Remember, next week is a really short week. We're only having Tuesday, Wednesday, Thursday, because Monday's a public holiday and Friday's a public holiday. Okay? We're good. Guys, thank you for joining. I will see you guys again tomorrow. Please make sure that you have the links for tomorrow's meeting. Screenshot it, copy it. I don't mind how you do it, just have it. Okay? And then I will see you guys tomorrow for organic reactions. Okay, and we're going to just get comfortable with them. Hope you have a fantastic day. Bye.